Cold on Earth feels brutal. Antarctic nights drop below minus 80 degrees Celsius and freeze steel solid, yet in cosmic terms that temperature is warm. Space itself is not truly empty. It glows faintly with leftover heat from the birth of the universe. Everywhere between galaxies, a thin radiation fills reality at just 2.7 degrees above absolute zero. This background temperature defines the natural climate of the cosmos. Anything colder than this must actively lose energy faster than the universe gives it. Absolute zero is minus 273.15 degrees Celsius. At that temperature, atoms stop vibrating and motion nearly vanishes. Reaching it perfectly is impossible because any interaction adds heat. The entire universe constantly radiates energy into everything. Even darkness is warm compared to the deepest cold possible. Yet some places come astonishingly close, colder than any laboratory humanity has ever built. Far from stars, inside giant molecular clouds, temperatures drop to just a few degrees above absolute zero. These clouds look empty but contain the raw material of future stars. Gravity slowly pulls atoms together while radiation escapes into space. The colder the cloud becomes, the easier it collapses. In darkness colder than imagination, new suns quietly begin forming. Some planetary nebulae are even colder. When dying stars shed their outer layers, the gas expands rapidly into vacuum. Expansion steals energy from atoms, cooling them dramatically. In certain nebulae, temperatures fall below the natural cosmic background itself. They temporarily become colder than space, creating bubbles of extreme cold drifting through the galaxy. One famous example is the Boomerang Nebula, located thousands of light years away. It holds the record for the coldest known natural place. Its temperature drops to about 1 degree above absolute zero. Gas racing outward at incredible speed cools faster than radiation can reheat it. For a brief cosmic moment, this dying star created a region colder than the universe surrounding it. Comets and distant solar systems also preserve ancient cold. Hidden in outer clouds far from starlight, they remain frozen for billions of years. Their ice contains material unchanged since planetary formation. When they fall inward toward a star, sunlight awakens them, releasing gases that have never warmed since the universe was young. Between galaxy clusters lie enormous voids. These regions contain almost no matter at all, with nothing to absorb radiation. Temperatures approach the universal minimum. If a human could exist there, no sensation of cold would occur. Heat would simply leave the body instantly. Warmth requires particles. In deep voids, there are almost none. Neutron stars reveal a different cold. Their surfaces are incredibly hot, but interiors cool rapidly through neutrino emission. Energy escapes straight through matter without resistance. Over time, these collapsed stars become dark and frozen remnants, colder than most planets despite once being stellar cores. Black holes may host the strangest cold of all. They emit Hawking radiation with a temperature inversely proportional to their mass. Massive black holes are unbelievably cold, colder than any nebula. A supermassive black hole at a galaxy center has a temperature barely above absolute zero, making darkness itself colder than deep space. In the far future, stars will burn out across the cosmos. Without new light sources, the background temperature will continue dropping as the universe expands. Galaxies will grow darker and colder for trillions of years. The cosmos is slowly freezing. Eventually, planets drift through interstellar darkness with no sun. Their surfaces become solid nitrogen and oxygen ice. Atmospheres collapse onto the ground. Oceans turn to rock-hard crystals. Worlds become silent frozen spheres orbiting dead stars. After unimaginable time, even white dwarfs cool into black dwarfs, objects that emit no visible light. The universe transitions from glowing to dark. Heat spreads thinner across expanding space. Particle interactions slow everywhere. Chemistry ends. No energy differences remain to power motion or life. Temperature approaches absolute zero across cosmic scales. This final era is called heat death. Not an explosion, but stillness. The universe becomes uniform and cold beyond comprehension. All warmth that once formed stars, planets, and living beings dissipates into near nothingness. The cosmos does not end in fire, but in quiet, freezing darkness. The coldest places in the universe are not only distant nebulae, they are the future itself. The ultimate fate of reality is silence, darkness, and a temperature almost indistinguishable from absolute zero.